Good morning, everyone. My name is Daniel Tong, and I lead the consulting practice of Hunt and Associates, a multidisciplined project management and engineering firm with a 25-year history providing customers across diverse industries with high-value professional services. Our mission of adding customer value has been focused on partnering with clients to create the future. I can think of no better example of that than our role as the owner's representative for Amogy, a rapidly growing Brooklyn-based startup founded by four MIT alumni in November 2020 with the goal of converting renewable ammonia into a sustainable power source to decarbonize the transportation sector. Their initial research led to the development of an innovative ammonia-to-power platform based on a best-in-class ammonia cracking catalyst capable of efficiently operating at lower reaction temperatures with high durability. After trace ammonia is removed from the reaction products, the cracked hydrogen can be used in fuel cells for onboard power generation, as a pilot fuel for ammonia combustion engines, or purified for other uses. Amogy's revolutionary power pack technology unlocks the potential for liquid ammonia as a hydrogen carrier, providing high efficiency conversion in a compact and highly portable design that has already been successfully demonstrated at real scale on a drone, farming tractor, and Class 8 semi truck in less than 2 years. Amogy is currently retrofitting a 1957 vintage tugboat running on diesel generators and electric motors with a 1 megawatt power pack, more than 3 times larger than the version tested in the semi truck, and capable of supporting more than 12 hours of operation on inland waterways. This will be the world's first ammonia powered vessel and a significant milestone for Amogy in accelerating the accessibility and scalability of clean energy in maritime applications. Now, for some context. Ammonia is a widely produced commodity chemical primarily used for nitrogen fertilizers today. It can be made green using renewable electricity, water, and air. It doesn't have to be stored at high pressure or deep cryogenic temperatures. It has 10 times the energy density of a lithium ion battery, and it has an existing, mature global production and distribution network. For all these reasons, ammonia is quickly emerging as a zero carbon fuel for stationary power generation, highly efficient energy vector, and leading alternative fuel for the international shipping industry, which is currently responsible for 3% of global GHG emissions, with some analysts forecasting that this could grow up to 10 to 13% by 2050 if unabated. To address this risk, the International Maritime Organization has adopted a set of short-term measures to achieve a 40% reduction in carbon intensity of all ships by 2030 compared to 2008 levels, and 50% reduction in annual GHG emissions by 2050. Now, because of long vessel lifetimes and slow fleet turnover, near-term innovation and adoption of commercially viable zero-emission technologies such as Amogy's are critical to steering the maritime transport sector onto the net zero pathway. This, in turn, will drive market demand for zero carbon fuels. Of these, ammonia is predicted to be the lowest cost and therefore predominant marine fuel for large ocean-going vessels. Amogy's path to full commercialization by 2024 includes an intense near-term focus on continued R&D efforts, product development, and expansion of its laboratory facilities in Houston in support of their go-to-market strategy. As a first mover, Amogy is continuously innovating in response to feedback from partners and regulators on what the market is looking for, specifically in hard-to-abate sectors such as maritime shipping and heavy-duty trucking, or other applications such as stationary power generation. So what does this mean for this audience exactly? Although Amogy handles all R&D for its core technology in-house, there are a number of other components and subsystems within the power pack which contribute to the overall cost, safety, performance, reliability, and durability of the system. This requires collaboration with vendors on innovative approaches to design components to fit within unique spatial constraints, monitoring of advancements in fuel cell technology for longer lifetimes and increased efficiency in maritime applications, and partnering with appropriate experts on the design of system interfaces to ensure safe and efficient operation in real-world applications. Perhaps equally important upstream of the Amogy technology, if the global market for green ammonia develops as expected to decarbonize both the agricultural and maritime shipping industries in the coming decades, there will be a need for a significant ramp up in green ammonia production, driving deployment of utility scale renewable power generation and commercial scale electrolyzers. In view of this, continued innovation at all steps of the green ammonia value chain will be critical to achieving net zero targets in the coming decades. The industry is primed for change. Amogy aims to eliminate 5 gigatons of CO2 equivalent emissions by 2040 via adoption of their technology, and we're excited to help them get there. I hope you all are too.